In this video, we're going to look at some more challenging counting problems. So if you don't already feel comfortable and confident with the basic problems using the fundamental counting principle or permutations or combinations, if you don't feel confident about, like, if you're like, what are those, then you'll want to go watch videos on those first before continuing with this video. All right, so one type of counting problem is the at least type, which could also be at most, but I'm going to stick to at least for this video. So examples would be like flipping a coin, and getting at least one tail. Another example would be picking an outfit and wearing at least one black item. Or we could roll 2 dice and get a sum of at least 8. And we'll actually do some calculations in the upcoming slides. But first, before we do that, secondly, actually, I want to talk about choosing from more than one category. So we can have, for example, choosing 5 books from 7 fictional books and 4 nonfiction. Actually, the way I worded that is a little bit unclear, so let me try again. Choosing 5 books from 7 fictional books and 5. Well, let me write it like this. And 5 non-fiction books. So those are the 2 categories, right? So we have 1 and 2. But we're going to pick 5 books altogether. It's just we're picking out of 2 subcategories, if you will. All right, so another option would be, picking, these are all really going to be combinations. So we're going to choosing let's say we're choosing 3 restaurants out of 2 Korean, 5 Mexican, and 3 Italian restaurants. All right, so those would be, that would be choosing out of 3 categories. The Korean restaurants, the Mexican restaurants, or the Italian restaurants. All right, so let's actually dive into some examples. So example 1, suppose you flip a coin 3 times. In how many ways can you have at least 2 heads? So I remember my sample space, and if you don't, you could generate it with a tree. But basically, we have these options. These are the, heads, tails, tails, and then we have tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So usually it's easiest to make sure you're systematic by doing a tree diagram, but I have a separate video on tree diagrams, and I know my heads and tails pretty well. So we're looking for at least 2 heads. So this first one has 3 heads. That's at least 2 heads. This one has 2 heads. This one has 2 heads, but the next one only has 1 head, so we're skipping that. That one has 2 heads, and then the rest of them don't have 2 heads. So here we have exactly 4 ways to get at least 2 heads. All right, so example number 2, suppose you roll 2 standard 6-sided dice. How many ways can you get an outcome where at least 1 die is odd? So remember, we're going to think about the die as being 2 different colors. So I'm going to think of 1 die as green and the other die as purple, because each die could be different, and we have to account for the fact that they each operate independent of each other. So we do have to have a way to think of them as being distinct die. For example, this and this are not the same outcome. They might have the same sum, but they are not necessarily the same outcome. Well, they aren't the same outcome. So in a sense, order matters. Order matters here. So there are 4 cases for this. And so I'm just going to draw my 4 cases. And so I'm going to draw the 2 dice for the 4 cases. All right, so the first case would be both are even. And the next case would be that this one's even and that one's odd. And this one's odd. And this one's even. And here they are both odd. So how do we figure this out? Well, this here is not what we're looking for, right? We don't want the cases when they're both even. We want the other ones where at least one is odd. This one's odd. Either the green one's odd, the purple one's odd, or they're both odd. So here, well, there's 3 ways for the green dice to be odd. there's 3 ways for the purple dice to be odd, and there's 3 times 3 ways for them to both be odd. So that's going to be 3 plus 3 plus 9. So we're going to get a 9, 12, so that's 15 ways. If you really want to check, you can check on a diagram. You can write out the whole sample space like I did here. But instead, what I broke it down into was I broke it into cases. So case 1, we don't need. And case 2, there's 3 of those. Case 3, there's 3 of those. And case 4, there's 9 of those. And so our total is 15. So both of these I would kind of classify as, just counting options in the sample space. So you have to know everything that's in the sample space. Drawing out the diagram may be necessary for you to answer these ones, either a tree diagram or a table. But this is another tool you can have in your arsenal for number 2, where you break it into cases and figure out how many options are in each case, and then you add each case. So I'm adding the cases, but here I'm multiplying because I have to roll 2 dice together. So I have to account for the fact that I can have a 1-1, I can have a 1-3, I can have a 1-5. I can also have a 3-1, 3-3, 3-5, and I can also have a 5-1, 5-3, and 5-5. So that is 9. And so multiplying, I have 3 choices here, and I have 3 choices here. So that's like using the FCP in there. All right, so now we're going to look at, actually I'm going to pause this video here and start a new video.